Hey everybody, Dr. A here, and in this video we are going to be exploring a second example of solving equation systems by the addition, or also called the elimination method. So in the given statement, we're being asked to solve using elimination, and we have a system of simultaneous equations. We have 4x1 minus 3x2 equals 25. And then we have negative 3x1 plus 8x2 equals 10, okay? So this is still two equations with two variables. Instead of using our, standard variable designations x and y, we're just using x1 and x2. So, remember, it doesn't exactly matter what you call a variable as long as you're consistent with it throughout the process of a problem. So, you could call this variables x1, x2, x and y, a, b, f1, f2, it doesn't matter. So we're just going with variables called x1 and x2 right now. So we're going to call this equation 1 and equation 2. Again, I like to label my equations. So under solution, remember you want to write all this down. Math is not a spectator sport. You got to write it down in order to best learn it. Okay, so let's take a look at this. Unlike our previous example, there's not a very obvious convenient cancellation right now. We have to create one. So if you remember in this method, we are going to multiply one equation by a value to create a convenient elimination of a variable when adding the two equations. Okay, so that's another way of saying add a multiple of one equation to the other equation in order to create a convenient elimination. Okay, now, what's cool about this is you don't always have to do it to just one equation. You could do it to both equations if you want, okay? So here's what's interesting about this. If you want to avoid a fraction, dealing with fractions, we can make this little amendment, okay? So we're going to say to avoid fractions, consider this. Watch what I'm going to do here. I'm going to multiply equation 1 by a constant, by a value, okay? And then I'm going to multiply equation 2 by another value such that we can add them together and wipe out one of the variables. Watch how I do it. I'm going to say let's multiply equation 1 by 3 and equation 2 by 4. What happens when I do this? Let's do it slowly. Multiply equation 1 by 3. 4x1 minus 3x2 equals 3 times 25. And, we distribute things out. And what do we end up getting? We'll get 12x1 minus 9x2 equals 75. And so this is our new version of equation 1. And then watch what I'm going to do to equation 2 now. I'm going to multiply equation 2 by the constant 4. Negative 3x1 plus 8x2 equals the constant 4 times 10. And I work this out. I get negative 12x1 plus 32x2 equals 40. And this is the new version of equation 2 over here. Maybe put my equation labels in brackets so we don't accidentally think we're multiplying some stuff together. So now let's stack these new versions of our equations. And this is all fine. I mean, think about it. You're multiplying an equation by a non-zero constant on both sides, so that's fine. That's all legal. We're not breaking any math laws here. So we're going to have 12x1 minus 9x2 equals 75. That's the new equation 1. And then the new equation 2, negative 12x1 plus 32x2 equals 40, okay? And we're going to stack these on top of each other, and we're going to add them together. And look what conveniently cancels, the x1 term. It becomes eliminated, okay? So that's eliminated, and then you're left with 23x2 equals 115. And you can solve for x2 and get a value of 5, and that's part of your answer. Now we're going to do a similar process. We're going to follow a similar process to eliminate x2 and solve for x1. So I'll put a note here, follow a similar process to eliminate x2 to solve for x1. All right, so looking back at the original equation, what are some values? And again, we can avoid fractions here by being slick with our values, but what are some values that we can use to multiply one or both of these equations by to cancel the x2 term and solve for x1 directly? Well, how about this? Again, if you want to avoid fractions, because sometimes we don't like dealing with fractions, you can multiply equation 1 by 8, and you can multiply equation 2 by 3, and you will generate a negative 24 associated with negative 24 coefficient of x2 in equation 1 and a positive 24 coefficient on x2 in equation 2. So let's do that then, okay? So we'll write that down. We're going to say a new version of equation 1 becomes 32x1 minus 24x2 equals 200. And then a new version of equation 2 becomes negative 9x1 plus 24x2 equals 30. And then we can add these together. And notice the x2 terms end up canceling, and we're left with 23x1 equals 230. And so x1 equals 10. So the solution is x1 equals 10, comma, x2 equals 5. And that concludes this video example of the addition elimination method. Thanks for watching.